You want to know how many graph questions are on there?
Yeah.
Four. You guys want to know how many are equations?
Yeah.
Let's see, 1, 2, 3, 4, 5, 6, 7, 8. Well, and everything else is either multiple choice, true or false, or definition, or explaining something, explaining a concept. Okay. All right, ready? Let's go. Okay. So this question is saying if you are looking at the 1 over psi s equation on the graph showing you 1 over the absolute value of water potential versus relative water deficit, and on that graph the linear equation is y equals minus 0.0354x plus 2.4351. what is the 1 over psi s if the relative water deficit equals 3.254? So what is it that we need to do first?
Determine what x is?
So, yes, that's perfect. So what is x in this format?
The RWD, relative water deficit.
Yes, thank you. Thank you. Thank you. Thank you. So do we know what relative water deficit is? Yes or no?
Okay.
Based
Yes.
off the question. Yes. Okay, what is it?
3.254.
Great, thank you. Okay, so we plug it in, correct? Correct?
Yes.
Yes.
Okay, thank you. Okay. Oh. And it comes out to okay. Let's see. 3, 5, 4. Somebody has 2.319. Are they correct? I don't have it. I haven't solved it yet.
That's what I got.
That's what I have.
That's what you got? Is that what the consensus got?
Yes.
Okay. Perfect. Okay. 2.3199. Okay. Now, do we need to solve it further? Yes or no?
No.
Correct. Why is that?
Because the graph already has 1 over the water potential, and that's what it asked for.
Exactly. So all it's asking for is 1 over psi s. And so it's not asking for psi s. So if it said, what would you do differently? If it didn't have this and it said psi s, what would you do differently? What would be the next step? Do you guys remember? Okay, so what Gerchance is saying, I'm hoping it was Gerchance that said it, and, is that right now, this is reading, sorry, you guys. This currently is reading this. Okay. But if I'm asking for you guys have to go through all this silliness with me. If it's asking for this, then what's the next step we need to do? Could also be say, so what is this? What is this equation here? Come on, you guys gotta help me out. Anybody? Thank you, Luca. It's the inverse. And so we have to take this number and we have to divide it by okay, which equals what?
0.43 or
Thank you.
41.
Okay, what else do we have to do when we get this? Okay, we took it out of the inverse.
Switch to negative, because that's gonna be a
Correct.
negative number.
Exactly, because psi s is negative, the answer would be negative 0.4311. Okay, so you guys see how that, the question wasn't asking that, but the question could ask that. And so no, you need to take it a step further if that's what it's asking for. Okay, good job. All right, let's move on to the next question. Okay, so it says if you want to dehydrate something, some vegetables using osmosis, which solute would you use to do it rapidly? Now, what this question is saying is it's saying to use the minus MIRT equation, okay? So when we use that equation, we know that the first part is -1, right? Because everybody always forgets to calculate this little negative. And when we learn from, oh, did we do it yet? Where is it at? This section here, we now need to do the same over here for the ionization. So what is the ionization for sucrose?
1.
Okay. What about sodium chloride?
2.
2. Calcium chloride?
3.
Yep. 3. Gosh, why does it not let me do this? I'll figure that out later. And then what about ammonium chloride?
2.
2. Okay. So cool thing is we can already rule out these two, right? We don't even have to calculate these two because they're both the same ion numbers. And where they're both the same ion numbers, we don't really know that they can't be both the answers, right? Okay. So you can choose the molarity to just be 1. Okay. So really the only number that's going to change is the ionization, whether it be sucrose or calcium chloride. Okay. And then rate is the constant 0083, I think, or 82, 83 times temperature, which is whatever the Celsius is times 273. We're going to just say 273 and assume Celsius is 0. Okay. So all you're doing is you are taking 0.0083 times 273, which gives you so this is going to be -1 times, for sucrose, 1 times 2.2659. Okay. So this is just basically saying that sucrose is going to be -2.2659. Am I correct?
Yeah.
Okay. So then for calcium chloride, it's 3. Okay. Which is, I don't know how to get this out of that. Oh, maybe this button. Oh, yeah. Okay. Equals 3 negative 6.7977. Okay. So the question is asking if you want to dehydrate something, okay, some vegetables, which solution should you use, sucrose or calcium?
Calcium chloride,
Correct. Why?
it's more negative, so water's gonna wanna go there.
Correct. Okay, does everyone get that? Okay, so now this question, he could switch it and he can say, if you want to hydrate some vegetables using osmosis, which solution would you use? And so in that case, which one would it be?
Sucrose.
Correct. Good job. Okay, next
I
one.
have a question actually.
Go.
So when you say Celsius will be 0, is it like the temperature? Like when you
Yeah,
put the temperature there?
so remember when we incubated the potatoes at 5 degrees,
Mm-hmm.
5 degrees Celsius?
Mm-hmm.
Then this number would change because it would be 278 because the potatoes were at 5 degrees Celsius. There might be a
Oh, so
yeah,
we add 273 to whatever temperature is given.
correct. Yeah.
Okay.
There'll be, I think there might be an example further down where it gives you like a temperature, where you'll see that. If not, I mean, we can practice one, if that'll make you feel better, or if that'll help you.
No, I
But yeah,
understand. I understand.
okay, cool. Okay, so the next one is saying, what is the psi s of a solution if the temperature is 295 and the molarity will be 0.2? Okay. Hmm. Oh, so it's saying based off of this right here, right? Right. Hold on one second. Let me look at this. Oh, yeah. Okay. So this question is saying, based off our answer, okay, what is this how do you solve for this? Okay. So now it's saying, okay, this is the ionization. The ionization is calcium chloride at an ionization of 3. Okay. Then our molarity is 2. Okay. Our ions equals 3. Our gas constant and our temperature, sorry, our temperature is, this is what you're asking about, Jesse. Well, they already solved it. We don't need to do anything else. 295. Okay. Okay. So how would you solve for this? So you would do -1, because we can't forget the negative, right? 0.2. 3 is the ionization. I have seen people forget to put that 3 in there. Okay. Okay. 0.2 times 3 times 0.0083 times. Did you guys get 1.469?
Yes.
Okay. Wait, is it supposed to be negative 1.469?
Yeah, I got negative.
0.4691. Okay. And that's how you would solve that. Okay. Does that make sense?
Yeah.
Will we be given the constant, the R?
Yes. So when I give you the minus MIRT, I'll give you the gas constant and then the temperature. So you're just going to have to be able to, but I'm not going to tell you that M stands for molarity. I stands for the ions. R stands for, well, you'll know that R stands for the gas constant because I'll give that. And you know that T will stand for temperature because I give that to you. But I'm not going to tell you like the other stuff. So you guys will need to know how to fill in for that. Okay.
In general, when we're not given the gas constant, do we just safely assume that it's 0.083?
Correct. Anybody else? Good. Okay. So it says using the graph. This would be the graph. It said estimate psi W, psi S, and psi P of the potato at a relative water content at 95%. Okay. So, what are we doing? What do we need first? Sorry, let me give you this. What do we need first? This is the same as this one, except for this said deficit. This one says content. So what do we do to solve that other one? What do we use?
The slope?
Yep, good job. Okay. All right. Okay. So first of all, here's the slope. Okay. Okay. Now, what is X again?
The deficit?
Yes. Okay. So they gave us relative water content as 95. What do we need to do to make it deficit?
Subtract it by 100?
Yep. Okay. So then we plug it back into our equation. So one of the things you guys need to remember is pay attention to when we put percentages in this format, which is normal when we solve with relative with water potential, but for for the Beer's law, it's different. Beer's law, it's 0.95. Okay. So I don't want you to get mixed up on that. Okay. So Y, which also means, sorry, I'm going to copy this. I'm going to cheat. Oh. Okay, what's the answer to this? 256. What'd you guys get?
1.7766.
Excellent. That's what I got too. Okay. So what do we need to do now? Luca, you know the answer to this, bud.
Not Luca, but did we divide it or one over that number to get
Yep.
this,
Mm-hmm. Yep.
relative, or what do you call it? Water potential?
Yep. All of the above. Yep. 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 Okay. Why can't I figure this stuff out? All right. I'm just gonna put psi. You guys know what I'm talking about, right? Okay. All right. So that means we need to do 1 divided by, which equals right? Am I right? But let
Yeah,
me do
but
one more thing. Go ahead, sorry.
No, you forgot the 7. There's 2 7.
I forgot what?
1.77.
Oh wait, hold on. I see what you mean.
Mm,
Okay, let me try this again. Five, 6, 3, 2, 9. Right? Yes, no, maybe so.
Yeah.
2, 9. Okay, and it's negative, right? Okay. We all noticed that, right? Okay. So you answered part of the question because you answered psi s. Okay. So now you need to answer. So now you're going to go back and you're going to go, okay, if psi s is 0.56, you're going to go to the graph. Actually, you're going to look at relative water deficit, which is 5. And 5 is here. Let's make a line. Okay. Okay, so that means that 1 over water potential is what? 2.5, 2.5? Yes. Okay. So then we're going to go back and we're going to say, okay, 1 over equals 2.5. So what we need to do is we need to take the inverse out of that, right? Which is 1 divided by 2.5. Oh, come on. Which equals correct? Am I wrong? And because it's water potential, it's negative. Okay. So now you have the answer to that one. Did that make sense? Okay. So
I do have
now
a
we
question.
go.
So I noticed on the graph, he gave us the data for like 4.10, but he's gonna give us something in between the data points that we have to kind of eyeball it like you did.
Yeah.
Okay.
Yeah. Sometimes it'll be lucky where it'll land on a point. Then you can just read the opposite point. Sometimes not so lucky. You'll just have to guessmate. So in that case, what he does, what he looks at, because there's going to be some questions where he does like a plus or minus 5. So let's say that you disagree with me and you're like, you know what, Julie, I don't think that that's 2.5. I say that that's 2.8, or I say that that's 3, or I say that that's this point, and I'm going to say it's 274. As long as you show your work, that's the main point. Because he's not really looking, I mean, he's looking to see if you get the answer like roughly correct. But if the steps are there, that's the more important point value than actually getting the number like on point. And so, okay. Okay, so this means that psi W is minus 0.4. Okay. So just like we learned in class, we plug those into the equation, which is psi W equals psi S plus psi P. Okay. Which means that negative 0.4 equals negative 0.5629. Don't even, I would just take it to 4 digits, you guys. I wouldn't even go further than 4. Plus psi p which means that psi p equals what? Yep. And because it's positive, it is correct. Okay. So then therefore this answer is psi w, which is right here. Psi s, which is right here.
How did you get that
And then psi p.
answer? Ooh.
Go. What going on? What? What happened?
How did you get that answer?
How did I get the answer for which one?
Psi p.
Psi p, this is the equation. So when you rewrite it, remember this is algebra. So
Oh,
yeah, so when we solve for psi p, which we're solving for here, we're going to take this number and we're going to add it here. So it's negative, we're going to turn it to positive. So then it winds up being 0.5629 minus, because water potential is negative 3, 4, right? Equals psi p. So when I subtracted those two numbers, it gave me that one. Okay.
yeah, correct.
Okay, cool. All right. Okay, so now it says using the graph, it's saying the same thing, but if relative water concept is 28%. So we know this is a linear equation we're going to follow. Oops. Okay. Relative water content is 28, which means relative water deficit is, which equals, yep, thank you. Okay. Then we plug everything into the equation, which is negative 0.25, so 0.256. Okay. So did you guys get this number? Okay. So we have to take that out of the inverse. That means it's 1 divided by 0.0614, which equals Is that what you guys got? Yep, thank you. And then we have to make that negative because it is psi s. Okay, now we got that far, right? Then we said, okay. So relative water deficit is 72. Which is over here, okay? Which means that psi p is what? We don't have to even go any further. What's psi p?
0.
Mm-hmm. Which means that psi w is what?
Equal to psi s.
Correct. Do you guys see how he got that?
No.
Okay. So relative water deficit is 72%. So when I went here, this is the relative water deficit line. And 72% is right here. It's like way off this line here. So remember that this little red thing that you're seeing right here, this is your 1 over psi s line, okay? And that this point right here I was hoping I didn't do that. This point is incipient plasmolysis. So that means all of these points afterwards, there's pressure potential added to it, okay? So all of this space here, that's pressure potential. So that means everything from this point going towards the right has no pressure potential. So if our relative water deficit is reading over here, so one of our points is going to read over here, then that means that psi p is psi w. And when we go to, psi p is 0. It has no pressure. So when we look at the equation, psi w equals psi s plus psi p. Remember, we said if we want to know what psi w is, it is equal to psi s when psi p is 0. Okay? Does that make sense?
Okay.
We're good? So we
Yeah.
didn't need to do any calculations further beyond psi s because we figured out based off of this graph that psi p is 0. So psi w equals psi s, and therefore it's the same answer. Okay?
So even if the relative water deficit was like, say at 30, the pressure would still be 0? Or because it's after that point?
Correct. Correct. Does everyone get that? Okay. All right, let's go on. Okay, so remember we crossed all these out, so we don't need to know any of this. Okay. Okay. Now, this is information that is in your lab manual. Okay, so it's saying that if absorbance increase, when we look at Beer's law, if absorbance increases, what else increases?
So concentration?
Correct. So they are parallel to each other, okay? Okay, when energy is not absorbed, did I cross this one out? Let me see. Sorry. Yeah, no, that's it. Okay, when energy is not absorbed, what is it called? I have that lab here. He says it starts with a T. It's in your lab manual. Okay, how about we go back to that one? Give you guys time to look at it in the lab manual. Okay. I'm going to highlight it so we know to revisit it. Okay. What is the absorbent coefficient of this molecule? So the absorbance coefficient, and he's referring to all these here. Do you guys remember what the absorbent coefficient was? The equation. You guys are killing me.
L times M.
The ECL.
Oh, yeah.
Yeah. Remember, we're now in Beer's law. We're not in water potential. I know. And it's you guys got to remember to keep them separate because we do things different. So it's saying, what is the absorbance coefficient of this molecule? So that was the thing that we were going over a couple of days ago when we're now solving for the absorbent coefficient, which is E. Oh. And it's absorbance divided by concentration and length, okay? We already know the length because the length is 1 centimeter, okay? And we know the absorbance because the absorbance is right here and we know the concentration. So A for the first one is 0.27. Concentration 0.2. Length is 1 because it's 1 centimeter of the cuvette. Okay. So when we plug this in, somebody solve it already? Am I correct?
Yeah.
Okay. So that is for the first one, and then you continue to solve for the rest. Okay? Does that make sense? Or do we want to do one more?
Please do one more.
Okay, sure. Okay. So the next one we're going to choose is I will choose absorbance of 0.55, which the concentration is 0.40, and the length of the cuvette is 1. Okay. So we plug the equation in. Okay. 0.4. right? Am I right?
Yes.
Okay, good. All right, does everyone understand how we got that? Okay, so he might do something where he might ask you for what's the concentration and you have the absorbent coefficient, or what's the or what's the, yeah, he'll probably, I don't think he'll ask you for what the absorbance is, but he will ask you, he could ask you for the concentration or the absorbent coefficient. So just know how to solve that frontwards and backwards, okay? I don't, I'm gonna look for number 4 really quick. I don't think I saw anything like that. Yeah, don't worry about 4. He's not gonna give you, there's nothing like that on the exam. Okay. So number 5, if sample A has an absorbance of 0.84 and sample B has an absorbance of 0.63, which one is less concentrated? Sample A or sample B?
Sample B because the absorbance is lower.
Correct. Because we know from the definition that absorbance equals concentration. And so therefore, because that's less, that's what that is. Okay, so sample B. Okay, so this question is, why do you need a blank? Why do you need a blank?
Because that's the control for the experiment.
Correct. Control and to tare the machine, okay? Okay, what factors might affect your measurements in the spectrometer? Okay, so we talked about this with the beer, and you can use the beer as an example. So what do we need the beer to be in order for it not to mess with the absorbance?
That'll be flat, so there's no bubbles.
Correct. No bubbles in it. What else?
Smudges on the glass.
I'm sorry, say it again.
Smudges like fingerprints on the
Yep.
glass.
Exactly. Fingerprints, scratches, anything else?
Doesn't it have to have like 1 ml?
Does it have to have what?
Like 1 milliliter? Like it can't be like,
Yeah, yeah. I'm not
so
sure.
it needs to be to
It
the
needs to
line.
be, yeah, it does need to be 1 mil. Trying to think if it's less than 1 mil, it might, yeah, you're right. It could affect that. So yeah. Okay, anything else?
The temperature of the sample.
Yes, thank you. Yep. It needs to be room temperature because we don't want condensation. And then one more thing that we didn't, I don't know, I know it's in the PowerPoint and I know it's in the manual, but the molecule in which we're measuring cannot be the same as the molecule. It cannot be the same wavelength, right? Because if I'm looking for example, when we were looking at chlorophyll A, if at 263, if chlorophyll B measures at 263, then we're unable to look at A and B at 263 because we don't know which one is A and which one is B. Does that make sense? So the molecules can't be measured can't be I don't want to say the same molecules. Okay, best way to say it is other molecules within the cannot absorb at the same wavelength as the molecule of interest. Does that make sense? Okay. So there's a couple examples. It might ask you like to name things. Okay. If a molecule has a lesser absorbent coefficient, how does it affect the slope? You know what? Cross this one out. We're not, he's not going to ask you that. Why did you choose acetone as a solvent for the chlorophyll extract?
I think you said we had to like break up the cells and get the chlorophyll out of the like plant cells.
Yes, correct. The acetone breaks the cell wall to access the chlorophyll molecules. Okay, good job. Okay. I'm not sure if we discussed this, but because you guys did really good. If your absorbance is over 1, is that an accurate measurement of the sample that we're doing the spectrometer of? Correct. No, it isn't. So how do we fix that? There's a couple ways we can fix that.
Dilute
So
it
if
more?
I'm sorry?
Can you dilute it more?
Right. Yes, absolutely. So the first thing that I would do is before dilution is I would just check to see is our is the machine set to the right wavelength that we're using? Because sometimes we probably forgot to change that wavelength, and so therefore we're getting a reading over 1. So I would double check to make sure we did the wavelength correct. Okay. I would double check to make sure we don't have anything that we discussed up here that is interrupting the absorbance of that solution. I would run a blank through it again and then tear it and then run it. And if it's giving me over 1 for the second time after I've double checked to make sure everything else was correct, I troubleshooted the other things, then exactly what you're saying, I would then dilute it and then run it again. And then so that's why we do the calculations that we did is we're taking it out of dilution. Okay. Does that make sense? Mm. Okay. So here is I love these questions. Okay. To measure chlorophyll, we removed 100 microliters of supernatant and mixed it in a cuvette using 900 microliters of acetone. The result was a 10x dilution. If I use 100 microliters of supernatant and 400 microliters of acetone, what would the dilution be? Correct. 5x. Do you guys remember how we did that? It can be 5x. It could also be written 1 to 4. 1 part 1 part acetone, 4 parts. I'm sorry, 1 part, what do you call it? 1 part, supernatant and 4 parts acetone. And so, but the answer is 5x, okay? Do you guys see how we got that? We're good? Okay. So when calculating total chlorophyll and chlorophyll A and chlorophyll B, why do we multiply the concentration in the cuvette by 10? When we were going over this in class, why did we multiply it by 10?
Was that to get rid of the dilution? The 10
Yes,
times dilution?
exactly. It is because we are oops, taking it out of dilution from the cuvette to know the concentration in the centrifuge tube. Okay. Okay, so now we're here with the calculations. Okay, and it says that we have weighed 0.3 grams of fresh weight tissue, and we homogenized it with that little glass thing. And oh no, so we mashed it up, and we wound up using 8.11 milliliters of acetone. You guys then with that, so this means everything that was in the second centrifuge tube after we centrifuged it and whatnot. Okay. Then they created a 7x dilution of the supernatant. The sample was analyzed at 645 and it got this absorbance, and 663 at this other. What is the total chlorophyll? You are given the equation. So it wants you to know, it wants you to say, okay, I want to know it in the cuvette, I want to know it in the centrifuge tube, and I want to know it in the leaf. So the first thing we're going to need to do is what?
Plug in the absorbance numbers into the formula to get the cuvette.
Yes. Okay. Make sure you guys have the units right, okay? This is the constant, so this is always stays the same. And 645 is 101. This is also a constant. Okay. Is this what everybody got? Did I do right?
Yeah.
Okay, great. Okay, so now we got the total chlorophyll. What's the next step?
Would you multiply it by 7 for what is in the cuvette?
Correct. Okay. Okay, what's next?
I think we multiplied it by the volume, the 8.11,
Correct.
to get the centrifuge tube.
Yep. Okay, what's next? I feel like I'm missing a step. Let me look at something. Mm, Can I look at something, you guys? I feel like I'm missing a step. I'm sorry. Okay. That's fine. That's fine. That's fine. That's fine. Okay. I don't know. I don't know what I'm thinking. Okay. Okay, sorry about that, you guys. Okay, so now we know what's in the centrifuge tube. And then what's next? What's left?
I think we divided it by the fresh weight, but we have to convert it to milligrams first, right?
Correct. Right. Okay, so we're gonna take 0.2248 divided by 0.3 multiplied by 1,000. Okay. Okay? And then that's it. We're good? We're good, we're good, we're good.
Yeah.
Okay. Okay. So on this one, it's saying each column represents the data collected for the sample that was in the cuvette that was made from combining 100 to 900. So that's a dilution factor of 10x, right? And so it's saying if the concentration of the cuvette is 0.2 milligrams per milliliter, after multiplying by the dilution factor, then the original concentration in their centrifuge 2 is 2.0 milligrams. So basically they just took this, they already did the equation for you, or she's giving you the example of that. So it wants you to solve total chlorophyll. Oh, it wants you to solve total chlorophyll for all of these components. Okay. So, I hate how she did this though. So, we can solve for a couple of them. Okay. Um, let's see. Trying to figure out how to rewrite this so that oops. Let me do one example for this and then you guys can go from there. Okay. So one of these examples is the leaf. Okay, the leaf weight is 0.7 grams. Okay. Next is acetone in centrifuge tubes is 9 milliliters. Okay. What did she say? Our cuvette was a 10x. That's just giving an example. Oh yeah, so it's a 10x dilution, okay? Does everyone see where I'm getting that, right? Yes, thumbs up, thumbs up. Okay.
No, where?
So we got it. I got 10x because it says it right here. It
Okay.
says, yeah, it says a one part sample, 9 parts acetone, so it's a 10x. Okay. And then I'm working on this first column right here. Okay.
Mm.
So that's why I'm rewriting it down here so it's easier to understand. Okay. And then our A645 absorbance is 0.2699 and our A663 absorbance is 0.1103. So it says first thing we're going to solve is total chlorophyll. Okay. Which the equation is coefficient. And I'm going to give this to you. You don't need to memorize this. Nope, I did this wrong. Okay. Nobody caught that. Okay. Oh. Somebody needs to be doing the calculations for me, please. Anybody else want to confirm what Shasid got?
I got that as
Yeah,
well.
that's right.
Okay. Thank you. Okay. Then it's saying total chlorophyll in cuvette. Okay. So we just know we don't know that. So that means we need to do what? Multiply it by what?
10.
Yep. Which equals, right?
Yeah.
Okay. So the next question it's asking is, okay, tell me what it is in a centrifuge tube. Times what?
The 9 milliliters of,
Thank
basically the
you.
volume of the centrifuge tube.
Yep. Mm-hmm. Which equals?
0.5703.
703. Okay. Okay. Now, it tells you stop right there. We don't need to do any more. Okay. So next thing we need to do is it says, okay, calculate chlorophyll A in that cuvette. Okay. So chlorophyll A's equation this is the constant. Now remember that the A and B are negative or are minus, not positive. Okay. which means that and if I can have somebody already start doing the calculation for me. Anybody?
I got 0.0067.
Is that what everybody else got? Everybody else? I need another person to confirm. Anybody?
Yes, I got the same thing.
Okay, thank you. I appreciate that. Okay, so now it's saying, okay, solve it for the cuvette and the centrifuge. So what are we doing again? What are we multiplying it by?
10 for the dilution.
Mm-hmm. Thank you. Which equals then it says which means we're multiplying it by
9.
mm-hmm. Is everybody seeing where these numbers are coming from?
Yeah.
Okay. Am I right? Am I right? Okay. So then now it says, let's do it for chlorophyll B. Okay. This is the constant. And this is minus. And then I'm going to rewrite the equation. Does anybody have a number for me yet?
Got 0.0057.
0.0057. Is she correct? Can we have somebody confirm?
Yes, you're correct.
Okay. Thank you. And now we need to times the dilution which equals 0.057. Correct me if I'm wrong, please. Okay. And then we need to do the center. Is that what it said next? Centrifuge tube? Yeah. Zero 0.57 milligram per liters times 9, which equals what?
I got 0.513.
0.513?
Yeah.
Excellent. Okay. Good job. Okay. Now it says, okay, what's the AB ratio? So that means that we're going to take this number. Oh, sorry. No. This number. Okay. And this number. And we're going to divide it by each other. Exactly what it says. Okay. Yep, I got that answer too. So that's the ratio. Okay. So that gets us there. And then it now wants you to take that. It wants to find out chlorophyll A, chlorophyll B, and chlorophyll and total chlorophyll in the leaf tissue. So our leaf weight was 0.7 grams. It's right here. Okay. Write that down. So just like we did up here, we are just going to divide it. Okay. So first one, it says chlorophyll A, which is, oh, 0.0603. Um, okay. Because we need to convert it to milligrams, right? So 0.0603 by 700 is 1, 2, 3, 4, 5, 6. that what everybody got?
Yeah.
Okay. Now let's solve it for B. Okay, B is okay. Is that what you guys got? Yes, no, maybe so. Or chlorophyll B.
Yeah.
Okay, good. Thank you. What was our total chlorophyll number? Mm, okay, is that what you got?
Yes.
Okay, and that's pretty much it. And then you guys can just practice with the other samples or the other examples. Okay, does anybody have any questions? Things that need to be revisited?
Is this chart that we just did for practice, or is something like this going to be an exam where we got to do like
No, this is for practice.
Okay,
This
cool.
is just to give you guys practice on different ones. On the exam, it's going to be very similar to your quiz.
Thank you.
Question 12. Go up. Right here, this one. Okay, great. Do you understand it, It's Ali? Okay. Anybody else?
Can you
Very
go back to
last
the bottom?
question.
Oh wait, so okay, I don't know who went first. Who wants to
I
go
just need
first?
to see the last question really quick. For the
The
total.
last question,
Yeah. Just
this one?
the very, very last one.
Tell me when to stop.
Keep going. The last page.
Oh, okay. All of this?
Yeah. The very, very last part. I just want to see if I did it right.
Oh, okay.
The total. Okay, got it.
Okay, cool.
Mhm.
Jesse, did you have a question?
It was the same one.
Oh, okay. Anybody else? Anybody?
Could we go over the answer to number 2 on the Beer's Law? I can't
Number-
find it in the lab manual. I've tried searching for that.
Oh,
I feel stupid.
oh no. You know what? It could be an old question too. Give me a second. Let me. I don't think I have brought the lab here. I think I left the lab in the actual lab. Let me make a bunch of. I know the answer and I can't think of it off the top of my head. It's like, oh my gosh. Okay, here, let me look it up. Oh, it's Beer's Law, right?
Yeah.
Okay, look really quick. It's like transverse or I'm trying to remember. I'm getting it confused with another word. Maybe it isn't in here. I'm wondering if it's in my old one. Okay. Let me see if it's in PowerPoint. We'll learn it together. I see it too in my head. Yes. Thank you, Chance. That is it. Transmitted. And so, okay. I'll make sure it's not on the exam though. I didn't think it was, to be honest. Let me look at it actually really quick. But yeah, you're correct. Good chance it is transmitted. Okay, let me look really quick. One more time. Boom, 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 boom. 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 Mm-hmm. Mm-hmm. Yeah, that question is not on the exam either. Okay. So don't stress about it. Any other questions?
I guess just follow up to that answer. Is he trying to refer to like the fret thing he talked about in lecture where it like shares the energy with like a neighboring cell to get it to the
Yes,
reaction center?
exactly.
Okay.
All of the above. Anybody else?
Can you go over 1 and 2 on water potential?
1 and 2 for water potential. This one? These two?
Yeah, yeah,
Did these in class? Just kidding.
yeah.
Okay. No, it's okay. It's okay. I'm just teasing you. Actually, there's some people on here that were sick and unable to attend class. So the fact that you're bringing it up, you're helping them out. So I'm just teasing you. Okay. So it says you have calculated 1 over psi s to be 1.576 and have a water potential or psi w of negative 0.243. Using the water potential equation, psi w equals psi s plus psi p, what, please calculate for psi p. So you already know that psi w equals what? Go, Jesse.
Negative 0.243.
Good job.
Thank you.
And that it's correct because why?
It's negative.
Yes, awesome. Okay.
Thank you.
But you have the inverse and absolute value of psi s, right?
Mhm.
Right. Okay, so what do we got to do to fix that? What do we got to do?
Mm,
Somebody help her out. What do we always do when it's like this? Yes, good chance. We're dividing it by 1. Okay. Which equals what? Go, Jesse. You got this.
all right, give me a minute. Hold on.
Yep.
Oh, damn. Hold on. Sorry.
That's okay.
0.634.
Yep. Exactly.
Right.
Okay. So what's wrong with it? What does it need to be multiplied? It's got one more step. Yep. Good job, Luca. So it needs to be multiplied by 1 because we have to make it negative. By -1 because we have to make it negative. So psi s, oof, caca. Psi s equals negative 0.6345. Correct? Jesse? Jesse.
Yeah.
Okay. Okay. Now we know what psi w is. And we know what psi s is. We need to know what psi p is. Okay. So psi w is negative 0.243 and it equals psi s, which is negative 0.6345 plus psi p. So the equation is rewritten positive 6345 because it's going to the other side minus 0.243, which equals what? Thank you, Amanda. Good grief. 0. And it is correct because what?
It's positive.
Yep. There you go. Good job. You see how we got that?
Yeah.
Okay. Now let's go over to. Okay. It says, what is the solute potential of a 0.2 molarity of table salt solution incubated at 36 degrees Celsius? So this is a question that's asking you to use that equation minus MIRT. Okay. What is the molarity?
is 0.2.
Correct. What is the ionization?
Of table salt?
Yep.
Hmm.
Table salt is what?
2?
It's 2, right?
Yeah. Okay. Then our gas constant. You don't need to memorize that. I give it to you. Okay. And our temperature is Celsius plus
309.
273 gives us Kelvin. So in this case, it's going to be 36 plus 273, which equals 309. Is that right? And now we just plug it in. -1, so we don't forget that negative up front, right? The M, the ionization. Remember, I told you people forget that. The gas constant and our temperature. And we get
Negative
Yep.
1.02588.
Yep. Perfect. That's it. Okay. Does that help you out?
Yeah,
Okay, cool.
thank you.
Awesome. Anybody else?
Can you do number 10 for the water potential lab? It's the question that says, what does the relative water content tell you? I wasn't sure if I was supposed to delete that one or not.
Let me see. Am I going the right direction for it? This
Yes,
question?
it's
This one?
number 12.
Which one? 12?
Yeah.
I think I crossed that out. Yeah, I crossed it out. 11 and 12 are crossed out.
Okay.
Because that question's written. It's basically to say, okay, relative water content tells you, if you know what relative water content is, then you know what relative water deficit is because you minus it from 100. And so that's what it's basically saying. And then when it's saying on the numerical range, it's saying that when we look at this graph, that it's going to reach a point where we're over here in this range and it's no longer on the scale. But again, like, you don't need to know that for the exam. Okay. Any other questions?
Are we able to go over one on the quiz?
If you want to, yeah.
Okay.
Which quiz do you want to go over?
Number 2 on quiz 3.
Yeah. Number 2 on quiz 3. Okay. Okay. It says, using the graph above, estimate the value of psi s if the relative water content was 35, and then show your work. Okay. Now, so the first thing we need to know, relative water content, okay, is 35, and we need to find relative water deficit. What do we do?
Is that where we look at the graph?
No.
Or is it the
Not
one
yet.
minus 35?
Yes, and then you look at the graph. Okay. So that is 65. Okay. So 65 is over here. Okay. And honestly, we can, even though it's over here, all it tells us is that there's no pressure potential. So what you're wanting to do as far as like the next step is you're wanting to find psi s by solving using the linear equation. Okay? Because that's what we did earlier. Oh my goodness, my fingers. Okay? Are you still with me, Alicia?
Yes.
Okay. So we're gonna plug in. So remember that y is actually
Is it the one over?
Yep.
Yes.
Yep. I'm gonna try to see if I can copy it off of here so I don't have to figure it out over there. Okay. Oh. So yeah, when we use that equation, that's what that means. So that's negative 0.237 times 65 plus 1.7442. So that equals
I got 1.602. Negative.
Wait, hang on. I haven't caught up. Is she right, you guys? Point. Oh, messed up here. 0.237. Let me catch up to you.
Okay.
Plus. Okay, so what did you get?
Negative 1.602.
I got 0.2037.
That's what I got.
Something wrong.
Yeah.
Oh, I did.
And-
I put the number wrong.
Did you forget the negative?
Yes, I did.
Okay. Yeah. And so those are the attention to details that you need to just take a deep breath when you start doing these equations, that you don't forget those minuses and pluses in the right place. Okay. So once we're here, then we need to do what?
Divide by 1 to get a.
Yep.
the
Good
psi W
job.
Or psi s.
Yep. 1 divided by 0.2037. Okay. That's going to equal 4.909, and then we have to multiply it by -1 to take it out of the absolute value, which gives us a psi s of negative 4.909. And that makes sense, right? Because this is where you stop here because it's only asking for psi s. And that makes sense because if we're at 65%, which is over here, that means we're way down over here in the negative value.
The graph has
Okay.
it as psi W, so did we just find psi W, not psi s?
All the question is asking is for
Oh,
psi
okay,
s, so
never
you
mind.
don't need to solve for psi w. But
You're
if
right.
it said, okay, tell me psi w and psi s and psi p, you would know that psi p is what? What's psi p?
0.
Exactly, which means that psi w equals
0.
nope.
Oh, sorry, negative 4.909.
Yes, there you go. There you go. There you go. Good job. Yeah, it equals psi s, which is as Sarah said, it's negative 4.909. Okay. Does anybody else have another question? Do you understand, Alicia?
Yes, thank you.
Uh-huh. Anybody else? Everybody ready to call it a night?
Would we be able to go over question 2 on quiz 4?
Yeah, we can do
Just
that.
to practice a bit more.
Yeah. Okay, quiz 4. Question 2. 1, 2. Okay, yeah. Okay, it says using the absorbance equation, when the absorbance is 0.063 on 23% concentration of light beer, what does that, how do you solve for that? Okay, so how you would do that is, now remember I told you be careful with Beer's law's percentage and water potential percentages, okay? Because Beer's law puts the point in front of here, water potential does not. Okay? Again, I'm going to repeat that. Do not confuse the percentage when it comes to Beer's law with water concentration. Beer's law just drops the little percent sign and then uses the whole number versus, no, I'm sorry. Damn it. Okay. Water potential drops a percentage and uses the whole number as is. Beer's law does not. Beer's law puts a decimal in front of it. Okay. So when we look at this, we know that absorbance equals 0.063. Okay. We don't know what the absorbance oh my gosh, I can't even think of it anymore.
Coefficient?
Thank you. Coefficient is, I appreciate you right now. The absorbent coefficient, because we're trying to solve for that, okay? C, we do know the concentration because it says 23%, but we are writing it this way. Okay? And we know the length of the cuvette is always going to be 1. You're with me? Was it just see that was asking the question for this one?
Yes, sorry, my mic was off.
That's okay. It's okay. I just want to make sure you're with me. We got it.
Mhm.
Okay, cool. Okay, so we're rewriting the equation. Coefficient equals absorbance divided by concentration and length. Therefore, we rewrite it as absorbance concentration times length, which equals what?
I got 0.2739.
Okay, hold on. Divided by, you said 0.2739?
Yeah.
Okay. Good job. And that's it. Okay. Good?
Mhm.
Okay, anybody else? Anybody else have any more questions? You guys ready to call it a night? What did the poll say? Cupcakes. All right. I will bring some cupcakes. All All right, well then I'm just gonna let everyone go home. Yay, thank you. You guys are already home.
A quick
uh,
question.
yeah,
Okay, so the incipient point is where the two graphs meet, right? It's not where the point is at then?
wait, say it again.
The incipient point,
Uh-huh.
so that one would be where the two graphs meet. It's not where the dot is at, right?
It's where the two graphs can meet. Yeah.
Okay. Okay.
Okay,
Just wanted
so
to-
technically you can say this one, here's a good example of what you're saying. Okay, technically it's right here, right? Where this arrow's at. But you can technically call this one incipient plasmolysis because it hasn't developed any pressure yet.
Okay.
Okay, but this point and this point, no, there's pressure already added to it when we're here. Okay.
Okay.
But everything on this side is plasmolyzed because it doesn't have nope, it doesn't have pressure potential.
Okay. Thank you.
Okay. Anybody else? Anybody else? Anybody else? All right, well that concludes our Zoom for today. And you guys have any questions? I'm gonna try my best to check emails daily between now and then if you guys have any more additional questions, okay? All right, well, everyone have a good night.
Thank you.
Thank you.
Thank you. Have a good night.
You too.
Thanks
Thanks.
for the cookies. I mean,
Oh,
cupcakes.
well, we'll see when you